Welcome, ladies and gentlemen, to your video lesson for 12.2. This is solving systems of linear inequalities. Good news about today's lesson is that you already know about 90% of what you need to know in order to be successful in this lesson if you remember how to graph a linear inequality. So that's good news. But before I talk any more about that, we're going to dive into our warm-up, review a little bit of other system solving situations, and then we'll get into the lesson for today. So let's talk about this one. Warm up here. Kristen spent, I want to get my right pen before I start talking here. I'll go with that color right now. All right, so Kristen spent $131 on pants and shirts. So Kristen's buying two different things, and it cost her $131. Those things are pants and shirts. Where she was shopping, all pants cost $28 and all shirts cost $15. If she bought a total of 7 items, then how many of each did she buy? We're going to set up a system of equations to solve. We're going to define our variables. So really all of our information comes from just a couple sentences. Kristen spent $131 on 2 items, pants and shirts. And then where she was shopping, all the pants cost $28, all the shirts cost $15, and she bought a total of 7 items. Okay, so we want to know how much of each she bought. So what I did is right here, I defined X as the number of pants that she bought and Y as the number of shirts that she bought. I was able to write one equation on the bottom that was X plus Y, so the number of pants plus the number of shirts must be equal to the 7 items that she bought. But then the cost of each item times how many that Kristen bought should be $131. So that's where you get the $28 times the number of pants plus the $15 times the number of shirts is equal to 131 bucks. So there's my system. Now, the way it's written, the best thing I think of is solving this with elimination. So remember, that's where we have our variables lined up or equal sign lined up, and we get a variable to cancel out. It's not going to happen here because we have to multiply one of these equations by one number. And so in that case, I decided to cancel out the y's, which means I would have to multiply the bottom equation by negative 15, as you can see me doing right here. I have to distribute that negative 15 3 times. So I have a negative 15, and I rewrote this again, a negative 15x, a negative 15y, and a negative 105. Now, if I look at my equations, I notice that I can have the y's cancel out at this point. So y's are now going to cancel out. I'm going to end up with 13x is equal to 131 minus 105 is 26, which works out pretty nice because if I divide both sides by 13 to solve for x, I end up with x is equal to 2. And that means that Kristen bought 2 pairs of pants. So I can use that 2 to put it into any equation. I think the bottom equation is the best. So I'm substituting that into the bottom equation here. So there's that 2 going in for x into this equation. So 2 plus y is equal to 7. I subtract 2 from both sides to get y is equal to 7. And if I were to graph both these lines, they would intersect at the point 2 comma 5. But what that means in the context of the problem is that Kristen bought 2 pairs of pants and 5 shirts. So that's our warm-up for today. All right, so let's get into the lesson, graphing systems of linear inequalities. So our essential question today is how do you solve a system of linear inequalities? So remember, when we're graphing linear inequalities, if we do just one inequality, remember that would be like a line that could possibly be shaded or dashed, and then we shaded one side of that line. If we have a system of those, what that means is that we're graphing those on the same coordinate plane, and now our answer will become a double shaded region. Okay, so all of our answers, I know this kind of looks sloppy, but all of our answers for the one that I just quickly sketched out here would be inside of this box that I just drew. I would like heavily shade that. Okay, so that's all it is. That's why I said 90% of what you already need to know in order to graph systems of inequalities, because if you know how to graph one inequality, well, then just do it twice, and our double shaded region is our answer. So let's take a look at our first problem here. A little bit of another warm-up. So you can work a total of no more than 10 hours each week at your 2 jobs. So I have 2 jobs, but total I can't work more than 10 hours. House cleaning pays $5 per hour, and my sales job pays $8 per hour. I need to earn at least $56 each week just to pay my bills. So I'm going to write a system of inequalities that shows the various numbers of hours that you can work in each job. So we're going to circle back to this problem, and but I'm just planting the seed here that like things like at least means that they can't be equal to, right? Means that it could be that amount, but it could also be more. And no more than means that's a limit of 10 hours, right? So we actually got like some constraints here for which I have to work and earn my money. So let's scale back a little bit and review solving system of equations by graphing. And then we're going to graph one linear inequality, and then we're going to just get into the systems. So remember, when we solve systems by graphing, what we're doing is we're graphing two linear equations, equal signs, equations, and we're looking for those lines intersect. Now, these are in blue because if you're looking at this with your packet, this said like 14 and 15. That doesn't fit on the graph. So I change this. You can go ahead and change it as well. So my first line is y equals 7x minus 6. So minus 6 is the number that's all by itself. This is in slope-intercept form. And so the number that's all by itself is the y-intercept. So negative 6, 1, 2, 3, 4, 5, 6. And then my slope of 7x. Actually, I think I messed this up. Yes, I did. So here's what we got to do. It's not negative 6. It's going to be positive 6. So we're going to change this to positive 6. All right. I kind of wanted to see ahead of time what this was going to look like. So, oh, it's not. That's not the eraser. There we go. All right, positive 6. 1, 2, 3, 4, 5, 6. All right, so positive 6 is here. And then I run out of space going up 7 and then right 1, because remember, that's my slope, right? So I'm going to go down 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, and then left 1. Keep doing that. 1, 2, 3, 4, 5, 6, 7, and then left 1. And then this is an equation, so it's a solid line no matter what. And my line looks something like that. I'm going to switch colors here to blue. Graph the other line. So negative 3 is my y-intercept. So I'm down here. And negative 2 is my slope, so I will go down 1, 2, right 1. I'm going away from the line, so I'm going to go back to the direction. And if I go up to left 1, exactly opposite of the slope, then I end up getting the intersection, and it is right there. So my intersection is 1, 1 for that problem. Now, let's review how to graph a linear inequality. Now, we have a couple things we got to remember. We're going to have shading in this, right? And we're going to have a solid or dashed line. Everything else about graphing it is exactly the same. So if you're going to use the intercepts method, find the x and y intercept, plot them, connect the points. If you're going to solve for y, solve for y. But you have to remember that in an inequality, when you divide by negative, you got to flip that sign. I'm going to solve this one for y just to kind of remind you of that. So I'm going to subtract 8x minus 8x. So I got negative 4y is greater than or equal to that negative 8x plus 12. Remember, these are unlike terms, right? So I can't combine them. That says 12, but I should probably just fix that, make it better. 12, that looks slightly better. All right, now I'm going to divide by that negative 4. Remember, when I divide by the negative, I have to flip the sign. So I'm just going to do that right away so I don't forget. And so I end up with y is less than or equal to negative divided by negative is positive. 8 divided by 4 is 2x. And then 12 divided by negative 4 is negative 3. So my y-intercept is negative 3, which is right here. And my slope is 2. So I go up 2, right 1, up 2, right 1, ba-doom, 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 ba-doom. All right, and there's my line. Now that I have my line started, I have to consider if it's solid or dashed. So remember, if it is an inequality symbol that has a line underneath, all of these are solid lines. And if it's an inequality that does not have that, all of those are dashed lines, right? So I have less than or equal to, so I know it's a solid line. So I will graph a solid line the best I can. It's a little bit tough with the equipment I have. And we also learned another trick that when it is solved for y, and only when it's solved for y, if the inequality is less than or equal to or less than, we shade below. And if it's greater than or equal to or just greater than, then we shade above. So this is less than or equal to, so I will shade this way. The other way that we decide what side to shade is by testing a point, usually 0, 0, right? And if it's true, we shade the side that has that point. If it's false, we shade the side that does not. So if I substitute in 0, 0 here, I would have 0 is less than 2 times 0 is 0. So I'm saying that 0 is less than -3. Well, is 0 less than -3? Of course it's not. So I tested 0, 0. It turned out to be false, so I shaded the other side of the line. Okay? So that's all of the stuff that we learned when we solved systemic inequality or regular linear inequalities. Now I think we're ready to do some system work. So we're going to start off kind of easy. And in your notes, you have practice graphs and then you have answer graphs. You're going to see what I mean by wanting to use a practice graph just through the example. So I'll explain it as we get there. So the first one, we're going to graph x is greater than 2. Remember, this is a vertical line. Anytime you have an equation that's in the form x equals a number or is less than a number greater, it's a vertical line through the x-axis and that number. So it's a vertical line through 2. It is a dashed line because I do not see the equal sign underneath it. So here's my line. Now, it says x is greater than 2. So where are the x values that are greater than 2? They're all to the right. Now, I'm not going to go crazy shading. So I'm just going to kind of do this. All right. That's one of them. I'll do the other one in a different color here. And so we'll do that in red. If y is greater than or equal to 1, well, that equation form, y equals a number or y is greater than it, whatever the symbol is a horizontal line through that number. So it's a horizontal line through 1. And I do have a line underneath, so I'm going to try my best to draw a straight line through 1. And again, it's greater than or equal to, so now I'm shading above that line. Now, what you're seeing is that in a system of inequalities, we end up with a double shaded region. Or if there's 3 of them, then it's a triple shaded region, or whatever the case may be. That is your solution. All of the solutions for this inequality will be right here. What that means is every single number in this little box or wherever you end up double shading will satisfy both of these, right? So let's just take example. This is the point like 10, 10. Okay. Is the x value of 10 greater than 2? Yep. Is the x or the y value of 10 greater than or equal to 1? Yes, it is. So everything in here is the double shaded region. Now, here's why you might want to use a practice graph and then an answer graph. So I'm going to go ahead and graph each of these lines, but I already know my double shaded region is just in this area here. So instead of shading everything, I'm only going to shade my actual answer. So I'm going to set. So dashed line at 2. I'm not going to get all the way down. Then I will just go ahead and shade everything that is here. So now it looks a little bit cleaner, okay? In the next other examples, I'm going to show you methods, how you don't have to do that practice graph and answer graph, and kind of like taking notes on the graph as you go through it, okay? All right, next example, another system of inequalities. This one is a little bit more complicated because we have one that's in slope-intercept form, and we have one that is in standard form. So I'm going to go straight to the answer graph, and I'm going to show you what I'm talking about when we say that. I'm going to take a little bit of notes on it and shade at the end. So I have y is less than 4 minus 2x. The number that's all by itself is positive 4, so I'm going to go with positive 4. 1, 2, 3, 4. I'm going to change my view on this here for a second. Nope, that's too much. Just want to be able to see the whole graph. And 150%, I think, is it. There we go. So I can see the graph in the equation. All right, so my y-intercept's at 4. And then my slope is negative 2. So that's negative 2 over 1, which means I will go down 2, right 1, down 2, right 1. And again, I'm not graphing that line yet, right? Because I got to double check, is it solid or dashed? So there's my line. And it indeed is dashed because there's no line underneath. So I go back and just add a few more dashes here. Kind of like some points in between the points. And there's my line. Okay. Now, I'm not going to shade this all in yet. Remember, if it's in slope intercept form, we can use that trick that if it's less than, it's shaded below. Where is below the line? Well, it's going to be that side of the line. So I'm just going to like draw little arrows here to kind of like make a note, like, oh, when I'm done, I'm shading that side of this line. And I'll do the same thing for the other one, and then we'll come up with that double shaded region without having the practice graph. So I'll switch colors here. And we'll graph the other one. Now this one's in standard form, so I'm going to do the x and y intercept. So my x-intercept. Remember, for an x-intercept, we substitute 0 in for y. So I'm left with 3x is greater than or equal to 12, divide by 3, divide by 3. I get x is greater than or equal to 4. So that's my y-intercept. The thing about this is that the inequality symbol really is not what I'm using here in order to find my x-intercept. I'm really using the math behind it to find the x value. So really, my x-intercept is 4, 0. I get an x value of 4. So 1, 2, 3, 4 is right here. For the y-intercept, so when you do a y-intercept, remember 0 goes in for x. So it leaves me with negative 2y is greater than or equal to 12. I'm going to divide by negative 12, which means my sign flips. But again, I'm not really paying attention to that because I'm just trying to get the y value. So I get y, let's just use the equal sign, is equal to negative 6. So I get the coordinate point 0, negative 6. Okay, so 0, negative 6 is 1, 2, 3, 4, 5, 6 right here. And now I'm going to connect those. And it is a solid line because I see a line underneath the graph. So I'm going to do that the best I can this way. And it's in standard form, so I'm going to test the point 0, 0. So over here, I'm going to do, all right, so 3x minus 2y is greater than or equal to 12. Here's why testing 0, 0 is super simple. It's standard form. 0 in for x, 0 in for y. 3 times 0, 0, negative 2 times 0, 0. We just get 0. And we just ask ourselves, is 0 greater than 12? Well, that's false, right? So we shade the other side. 0, 0 is here. We shade the other side. So that means I'm going to be over here, right? So let's take a look at the notes we got here. I am shading below the blue line and below the green line, which means my double shaded region will be right here. That's where it exists. So that's how you can use the kind of like taking notes, drawing those little arrows, so you don't have to use a practice graph and then an answer graph later. Let's go to our next example. So this one's got 3 now. This is no big deal. We're just doing 3 on 1. This is where actually taking notes on it is going to be huge because then we won't have like a messy practice graph. So let's take a look at what we got. We got y is less than 3. So I'm just going to go right to the answer graph. Dashed line, right? Horizontal line because it's y equals a number. I know it's less than, but it's going to be a horizontal line because of that. So I'm going to dash my, I'll denote this as green. And I'll dash my green line here. And again, I'm just going to take notes and saying, all right, I'm shading below that line. I'm going to pick a different color. Okay, now x is greater than negative 2. So if we have that form of x equals a number, again, it's greater than, that's okay. And it goes through negative 2. So negative 2 on the x-axis is right there. So this is also a dashed line. So I'm going to try to dash this. And this is x is greater than -2. So that means the things that are the x values that are greater than -2 are on the right-hand side. So I'm going to be shading here. Okay, so far it's this little box over here that is my double shaded region, but I do have a different line that goes through there. So we have to see what that's going to be like. And so for this one, I have y is greater than -1 plus x. So -1 in this is slope-intercept form. The number all by itself is the y-intercept. So -1, the y-intercept, that gets graphed right there. And then my slope of 1 means that I go up 1 to the right 1, up 1, right 1, up 1, right 1, up 1, right 1. And I'll complete the line that way. And again, this is another dashed line. So all of these are dashed lines, which is just a coincidence here. Add a couple more dashes if I can. All right. And again, this one's solved for y, so we can use that trick. This is greater than, so I'm shading actually above that line. So now what we end up with is below the green line, so in this half, to the right of the blue line, but then above the red line, which leaves me with just this little triangle in the middle. So that is my double shaded region. Okay, so again, if you can solve systems of linear inequalities, or if you can graph one linear inequality, you can graph two, and then the double shaded region is your answer. Let's double back here and think about what would happen if I asked you to take a look at a graph. Could you tell me what the inequalities were? So that's exactly what you're going to see on independent practice. That's what you're going to see right now. That's why we're practicing it. So let's take a look at A, right? So A looks like it's an oblique line, which means I'm going to have a slope and a y-intercept, right? So y equals blank x plus blank. I'm just going to observe, like, where's my y-intercept? So the y-intercept is negative or a +1. So that's going to go right there, all right? And what's my slope? I'm going to go up 2, right 1, up 2, right 1. That means my slope is 2 over 1, or just 2. So what is that equation for A? Y is equal to 2x plus 1. For B, that's a horizontal line. I know that takes the equation form y equals a number. Back up a second. I forgot about something. I forgot about the inequality part. This is the equation y. I want a different marker. This is the equation y. We're going to have some inequality symbol, slope of 2 plus 1. All right, so again, using that trick, right, that it is solved for y, and we shaded above, we know that it's going to be some form of greater than, and that line is solid, and we're going to have the equal sign. So it's y is greater than or equal to 2x plus 1. Cool. All right, so the next line here, that is a horizontal line. We know it's going to take the equation form y equals a number, but again, it's going to be an inequality because we have a dashed line that's shaded below. So y, and then what's the number, right? Where does it go through? Through 2. So what inequality symbol is going to go here? Well, I noticed that I'm shading below that, so it's going to be less than. And my line is dashed, so I know that I'm not going to have an equal sign. So this is my system of linear inequalities that are on this graph. So all you got to do is, if it's in slope-intercept form, recognize the y-intercept, plop it in, recognize the slope, plop it in, and then just go ahead and verify, like, oh, is it solid or dashed? Make sure you have the equal sign or not accordingly. And then if you've written it that way, then just ask yourself, is it shaded above or below? If it's shaded above, then it's greater than. If it's shaded below, it's less than. And if it's a horizontal or vertical line, those are pretty self-explanatory as well. All right, so back to the beginning problem that we started with. This is a contextual problem that will solve a real-world situation. And then the lesson that we had on this, we had a pretty good problem that modeled the same thing for a business. So something that you can actually use. So you can work a total of no more than 10 hours each week at your two jobs. House cleaning pays $5 per hour, and your sales job pays $8 per hour. You need to earn at least $56 each week to pay your bill, right? And write a graph of system, right? And graph. There's a typo here. Just messed me up. Write and graph a system of inequalities that shows the various numbers of hours you can work at each job to satisfy what you're trying to do here. Right? Less than 10 hours, earn over 56 bucks per week. Okay. So here's what I did. I said that X was going to be the number of house cleaning hours, which means right away I'm going to label this. Let's see. I'm going to call it HC hours, house cleaning hours. I said the Y is my sales job hours, so I kind of ran out of space here. This is going to be tough. I'm just going to, man, this is going to be really hard to do. I'm going to try to do this. Oh gosh, I'm trying to turn my tablet sideways. This is just not going to work. I'll do this. Sales hours. And because I get to work with cool stuff, I can do this. Even shrink it down to make it fit. All right, sales hours, done. Cool. So I labeled my axes accordingly for that. So here we go. Come up with the inequalities, we have to go back to what's said. It says you can work no more than 10 hours, right? So if X represents the hours of house cleaning and Y represents the total sales hours jobs, that means both of those combined can have to be less than or equal to, because I can work 10 hours, right? It just can't be more than that. Less than or equal to 10. And so that's the first inequality. The X plus Y is less than or equal to 10. I get paid money for each of those hours that I work, right? And that amount of money I get paid per hour, totaling all that money, must be greater than $56 because I have to earn at least $56. And it can be equal to, because at least means it can be also the same. So that's where I came up with $5 per hour times the amount of hours I work at the house cleaning job plus $8 per hour times the number of hours I work at the sales job is greater than or equal to 56. So I went ahead and started to solve these. The red line for the equation for the sales job, or I'm sorry, total amount of money, I went ahead and solved for Y. The Y-intercept is not a nice real number here, but it's okay. Or the X-intercept isn't real nice, but that's okay. So the equation that I got, you can see I'm subtracting 5X from both sides. They're unlike terms, so I cannot combine them. Then I divide by 8. My slope is not awesome, but it's negative 5/8. I should put an X in there. And then I get a Y-intercept of 7. So I'm going to graph that. I'm going to get a little bit finer pen here. So my Y-intercept is 7. That's right here. And I'm going down 1, 2, 3, 4, 5. And then I go to the right, 8. 1, 2, 3. Oh, 8 is right there. So there we go. Down 5, right 8. And that is a equal sign underneath there. So I'm going to graph an actual line. I'm going to grab actually the line tool. I'm just going to do it freehand. Best I can here. And I know that I'm shading underneath that line. Above that line. Because it has to be greater than. All right, so the other line, again, I solved that one for Y. So I subtracted X from both sides. And when I did that, I was done. Y is less than negative X plus 10. So my Y-intercept is 10. And then my slope is negative 1, which means if I go down 1 each time, I'm going to go right down to 10 as well. So there's my line for that. Drawing straight. That's not bad. Kind of slope down at the end. Okay. And now that is less than, so I'm shading below that. So what that means is that my double shaded region here, if I'm shading above the red line and below the blue line, exists, and I'll do it with like a highlighter here, exists right in this area. Okay? And so that means every coordinate point in here represents the combination of hours that I can work at the different jobs to meet my goal, right? No more than 10 hours, earning over 56 bucks per week. So just to illustrate that, I'm going to grab my pen. For instance, this point right here is in that double shaded region. What that means is I can work 3 hours at my house cleaning job, and I can work 6 hours at my sales job, and that would satisfy both of those constraints, okay? Or I can work 1 hour at the house cleaning job because maybe I hate it, and I can work 8 hours at my sales job, whatever the case may be, right? So these are all my options. that we can use for that scenario. Cool. I hope this helped you guys. I hope you're having a great day. I'm done. Peace.